Okay, first we're going to do part A, and we're going to do problem number 3. So problem number 3 says a shopper in a supermarket pushes a cart with a force of 35 newtons. So we know that the force is 35 newtons. Directed at an angle of 25 degrees downward from the horizontal. Find the work done by the shopper on the cart as the shopper moves along a 50-meter length of the aisle. Now, to totally understand this problem, what we should do first is draw a picture, because the picture is going to help us to visualize. Now, they told us that she's pushing on the cart, and the 25-degree angle, so let's say this is the cart, here's my force F, and they said this angle here is 25 degrees. Now, the key thing here is work is only done in the direction an object is displayed. Now, this object is moving like this, horizontally. So, the x component of this force does the work. So let's look at the picture. Here's the force. So my components from where I start to where I end up, I have head to tail. This is Fy and this is Fx. Now, you know how some of you memorize, like, oh, the horizontal is like one, like cosine, the other one's sine. You can't memorize, and this is what I'm talking about. Because this angle here, we want to find x, so again, that's cosine, and they do give it from the horizontal. So W is equal to SD cosine theta. So W is equal to 35 newtons times 50 meters times the cosine of 25 degrees. So now when we look at our calculator, the first thing I'm going to do is I'm going to press 25 cosine times 50 equals times 35 equals. And it comes out to be a large number. So when I did on the calculator, it comes out to be 1586 newtons times a meter. And then I'll put it in scientific notation, and it says 1.586, which this has two significant figures and this has two. So my final answer will be 1.6 times 10 to the 3, and a newton times a meter is a joule. So again, this problem is probably the hardest because it has the angle, and again, to make sure you draw a picture. When you draw a picture, you're not going to make a mistake. Let's look at number 4. Number 4 says if 2.0 joules of work, so we're given the work is equal to 2 joules, in raising a 180 gram apple. So the mass is equal to 180 grams. Now you know in physics everything has to be in kilograms. So right away I'm going to convert that. There's 1,000 grams in a kilogram. So 1, 2, 3. The mass is equal to 0.180 kilograms. How far was it lifted? So I want to find D. Now, here's the floor. Here's my apple. So now I want the apple to go, this is a vertical displacement. This is a vertical displacement. When you're not sure what to do, what do? You go to the end. So it says to find D, and it's like, maybe I'm not sure what to do. So write first your equation for work. Work is equal to F times D. Now I have the work, and I want to find the D, but what's all this force? Well, here the apple is being lifted vertically. So the force that's being displaced is the force of weight. So remember that F of G is equal to mg. Remember, in physics, you can't just forget an equation because you already had a test on it. You have to know all year long in physics that weight is mass times gravity. Sometimes they give you the mass, sometimes they give you the weight. So weight is equal to, this is going to be the force of weight because it's a vertical displacement. Well, weight is equal to mg times d. Remember, weight is equal to mass times gravity. So now, since I want to solve for D, I'm going to rearrange the equation and say D is equal to work divided by mg. All I did was divide this. So now I substitute in my values 2 joules divided by 0.180 kilograms times 9.8 meters per second squared. So D comes out to be 1.1 meters. So if I'm lifting something vertically, the force that's being resisted could just be the force of weight. And that's it.